Welcome, dear friends. Today, in this topic, I'm going to talk about load balancing. I'm going to include few hands-on lab exercises as well. So, Google load balancing is a game-changing technology that revolutionizes network communication. It empowers business to deliver reliable and high-performing applications. One key aspect of load balancing is its support for various communication network protocols, such as HTTP, TCP, and UDP. This flexibility enables it to handle a wide range of applications from web services to real time streaming and gaming. In a hands on lab exercise, you can experience the power of Google load balancing by deploying a sample application on the Google Cloud Platform. I'm going to configure and test the load balancer settings, multiple features. You will witness how it seamlessly distributes incoming requests, monitors server health, and dynamically adapts to changing network patterns. By engaging in this hands-on experience, you will gain practical knowledge and insights into capabilities of Google load balancing. Let's take a deeper look at it. So this is the relative location in the protocol stack of SSL and TLS. So what you see here, the OSI model, there are multiple layers. Physical is the first layer and application is the seventh layer. In between, there are five layers, totally seven layers. Before we want to see some analogy. Let's say whenever we talk about virtual servers, load balancers, we talk about communication between two different systems. We talk about protocols. We talk about HTTP, HTTPS, TLS, TCP, UDP, all these things. So the important layers are application layer, transport layer, and network layer. Why do we need this layer? Look at it. So computers basically use a number of protocols to communicate just like human, how we use the language for the communication. So these languages, for example, when I'm speaking in English, it has a proper structure and a syntax. Similar to that, computers use protocols. So if you want two systems to talk each other, they need to better understand the common language, which is called the protocols. So HTTP, TCP, HTTPS, TLS, UDP are different protocols at different layers. So there are multiple layers and multiple protocols. Network layer is responsible for transmitting the bits and bytes. So this is the one I'm talking about here. So whenever we talk about computers, it's just like zeros and ones. That's how the communication is between the network layers. It is responsible for transmitting or transferring the bits and bytes. Whenever we talk about two systems to talk each other, the communication happens over the network. The next important layer is the transport layer. So in the transport layer, two things we need to keep in mind. One is the priority over reliability versus priority over performance. The transport layer is responsible to ensure that the bits and bytes, the zeros and ones, are transferred properly. As we discussed, there are a number of systems which are in between, and if one of the systems in between, it's just like a router goes down or something happens due to the loss of data or whatever, the transport layer is responsible for ensuring that the bits and bytes in which this system sends are received properly by the system. The next important layer is the application layer. The application layer is the top of the chain. Application layer is where we build most of our applications, like email application, FTP application, web application like websites. So it communicates the data from the application layer into the transport layer. For example, we make REST API calls, we send emails, all of them are the application layer. Remember, whenever we talk about application layer, all the layers underneath are being leveraged, being used. So when we make a HTTP request, what it does, so if it is a HTTP, it connects to the transport layer using TCP. If I'm using an email, it uses SMTP protocol that connects to the TCP layer. Similarly, FTP and DNS. DNS uses UDP. Actually, I will come to that later. Now, when my website is using HTTPS, it uses SSL and TLS, which is a secure form of TCP. So if your application needs high performance, let's say you are doing a streaming application or you are developing a gaming application, you want high performance. And in those kind of scenarios, you might even skip one of the layer. Let's say you can skip application layer and directly talk to the transport layer. So in summary, there are multiple layers which are involved when two systems to talk to each other, right? The network layer uses the IP, which is Internet Protocol. This is the protocol which is used to transfer bits and bytes, and the network protocol is very unreliable. Yeah, you heard me right. The network protocol is very unreliable. Because when this sends some information, it goes over the network and the data might get lost over the network, and that's why we have this transport layer. In the transport layer, there are two important protocols. The first one is TCP, another one is UDP. Let's talk about the TCP. If I am sending 128 bytes of information, making sure the TCP it counts exactly 128 bytes of data is arrived and in right order. That is basically the TCP. The next one in this is TLS, which is Transport Layer Security Protocol. It is very similar to TCP. This one is very similar to TCP. However, because the data is going over the network, you would want to make sure it is encrypted. So TLS is actually a secure form of TCP. Let's come back to the other one. The other one is UDP, which is User Datagram Protocol. UDP is an alternative to TCP and it gives high importance to performance over reliability. This gives more importance to the performance, whereas the TCP gives more importance to reliability. For example, if I am sending set of bytes over the network, I'm okay with losing some of those bytes. There are applications where you want to send 128 bytes over the network and it's okay to receive only 124 bytes of them on the other side. But for this application, the performance is very, very important. So the good example is video streaming applications. So the next layer is the application layer. So application layer, we are very, very familiar with the HTTP protocol like a website. So if it is a secure form, encrypted data is need to be sent through the HTTP, we should use HTTPS. So let's this basically in a nutshell, SMTP be used for the email, FTP for transferring the files, and these are all the different application layers. So let's dive into our use case. So I hope the communication protocol at a high level, which gives you an impression about how these protocols is required and what form and why the application is used certain type of protocols. And this is my case study for today. Imagine I have a patient and provider health record microservices. So this application is deployed all across the globe. So the sample application is a healthcare microservices system. There are three services: patients, providers, and payers. User can perform CRUD operation like a create, read, update, and delete. Operate these on these services using a third-party middleware that utilizes the REST API. To ensure global accessibility and optimal performance, the application utilizes Google Cloud Platform in conjunction with Google load balancers. This architecture involves setting up multiple instance groups distributed across multiple regions. Each instance group hosts microservices, allowing users to be served by the nearest instance group. Implementation tasks for this application include designing these microservices, like for patient, provider, and payer. And parallelly in Google Cloud Platform, we need to set up the instance group. Instance group is nothing but a combination multiple virtual machines in the Google platform. Deploying the microservices, deploying patients, prescriber, and payer services to the respective instance group, ensuring that the services are properly configured and able to communicate to each other. Now, the Google load balancers. Setting up the Google load balancer is to distribute the incoming traffic among the instance group. configuring load balancing policies, health checks to ensure efficient resource utilization and high availability. And finally, once the setup is done, we test and monitor. So by leveraging Google load balancers with multiple instance group and distributing them across the region, this application achieves global scalability, fault tolerance, low latency access for the users. It showcases how Google Cloud Platform, combined with effective load balancing strategies, can enable the seamless operation of microservices in a healthcare context, serving users all around the globe. So, application specification, it should have an Apache server. It uses the port 80. It uses either HTTP or HTTPS protocol. It's going to have three microservices, one for patient, another one for provider, third one for the payer. So each microservice is going to reside in different region for global accessibility. Now let's take a look at it. How are we going to implement it? So when it comes to Google platform, there are three things as a part of the cloud load balancing is concerned. The terminology is critical. The backend, the group of endpoints that receive traffic from the Google Cloud Load Balancer. The front end is specify an IP address, port and protocol. This IP address is nothing but your clients. We send the request. Then finally, host and path rules, defining the rules redirecting the traffic to the appropriate backends. For example, my application cloud340b.com/patient /provider and payer. So based on the path, so you could route the traffic to the appropriate microservice and the backend. And also I can use the hosting instead of the path. I can use the host name like patient.cloud340b.com. It routes to the the instance group, and if it is patient provider.cloud340b, it routes to this one, and vice similarly to the other one. And based on the HTTP headers, so like post method, get method, so you could leverage it. So there are three different types available. So this is very important as a part of Google Cloud load balancing, and these all the terminology. Now directly get into the lab part of it. What's the first step? Log into the Google Cloud Console. I'm already logged in, and create a health check. How to do the health check creation? Go to the dashboard and go to my compute engine. Here there are a couple of ways you could do. If you go to the instance group and you see health check, click on it, create the health check. Now I'm going to create a health check. This is a global scope. It uses TCP and port. I'm going to use HTTP. And request path is, I'm going to leave this as default. I don't want to enable the logs right now because it's going to cost more. So, but for your application, you may need to enable the logs. So the health criteria is every 5 seconds, it's going to check the heartbeat of the server. And this is the health check. I'm creating it, and timer is 5 seconds. And the threshold is maximum continuous successes. It has to get 2 consecutive successes to make sure the server is actually working, is in an alive mode. So that's basically my configuration. Now click create. So the health check is actually the first step that I should create. The second one is I need to create an instance template. How to do it? In the left hand side of your menu navigation, under the virtual machines, there is an option called instance template. Click on it. Using the create instance template option here or a button right beneath, you click on either one of them. It gives a default, so I'm going to use the default value like my instance, my hyphen instance template 1. The machine is basically E2, and the configuration is E2 medium, which we discussed about what are the different presets available. This one E2 is, I'm using 1 to 2 logical CPU and the memory of 4 GB. I'll leave everything as is. Then in the identity in the API access, I'm going to leave it as is. In the firewall, I'm going to allow HTTP traffic. Let's go to the advanced configuration. In the advanced option, under the management, in the startup script, copy this. So what I'm going to do is I'm going to install the latest version of the OS or the software for the server and install the Apache. Then I'm going to ping that host name and put it in the index file. So click create. It's creating an instant template. Sometimes it takes less than 5-10 seconds, but sometimes a bit longer. But in our scenario, it's going to be pretty quick. The instance template is created. Now, next step is to create instant group, a managed instance group. How to do it? If you go to the instance group menu, underneath there is something called instance group. Click on it. So my architecture is basically, I'm going to create 3 instance group, one for patient, provider, and payer. So I'm going to create instance group 1, like patient, description. I'm going to choose the one I created, instance template. My zone is Central 1, Iowa. I'm going to leave this default. I need 2 instance minimum and max of 3 instance per microservice. Then CPU utilization is 60 by default, so I'm going to keep this as is. In the auto healing, I'm going to use the health check which I created, my health check. So it's going to ping the server before it route the incoming traffic. This is very critical because the health check has to be created for the auto healing option, because auto healing recreates virtual machines if your application cannot be reached by the health check. So I keep everything as default. So it is for the patient in central region, and the zone is also central. So minimum of 2 instances, max of 3 instances. Let's click create. So parallelly go to the next instance group. I'm going to create instance group 2. This is for provider. This is not the microservice, but this is an instance group. I will call that as MIG. Instance template is the one I already created. Here, instead of central, I'm going to choose West in Oregon. Zone is West 1 default. And here also 2 minimum number of instances and max of 3. Let me leave everything default. And the health check, I'm going to take my health check which I created before. Let's click create. Manage instance group creation takes a little longer, so I got to be a little patient. So I'll come back in a minute. So now the instance groups have been created. So let me refresh. Yep, it's created 2 instances, and this is the name of the template created. It's a managed one. So one in central, one in east. And let me go back to the VM instances. So it brought 4 instances, 4 virtual machines. As per our architecture, we need 2 more. So I'm going to create one more instance group, which is instance group 3 for payer. Here I'm say let's create in South Dallas. Same 2 instances, max of 3. Same configuration, everything remains same. And I choose the default option, keep the same instance configuration, and the health check I need to pick the one which I created. Boom. Then click create. So the instant group creation progress, let me go to the VM. So there are 6 VM, 2 VM per microservices. After I create the instance group, now I need to go back and create load balancing services. To the search, and I search for load balancing under the network services. Click on it, create load balancer. So this is the option that I want to show it to you, because the reason why I want to share different protocols. So if you create the load balancer, there are three options available. One is the application load balancer that uses HTTP and HTTPS. So this is for the typical web applications, leverages the HTTPS and HTTP protocol. And this is for the internet facing or internal, and can be deployed in a single or a multi-region. So this is the option one. The option two is network load balancer that uses TCP and SSL. We have this network load balancer that uses TCP SSL. In our scenario, we are not using this. All our microservices is going to leverage HTTP. So I want to click start configuration. So it uses two options, from internet to my VM. So this architecture diagram, if you look at it, this is coming from the internet. So it uses the cloud DNS, and directly the incoming traffic is being routed to the cloud load balancing. So that's basically the option. So when I click on start configuration, I use the first option, from internet to my VMs. And the second option is global or regional. Our application is a global configuration, so it uses global external application load balancer. Choose that option, click. And this is the three terminology: the front end configuration, back end configuration, routing rules. So why I want to show it to you, the terminology which we discussed. The back end is for the endpoint, the group of endpoint, the three managed instance groups that we created. And the front end is basically for the we gonna specify the IP address protocol. And the third one is the host and path rules, the host and path rules, which you're gonna talk about it in a while. So now the front end configuration, it uses the HTTP IP4 version, ephemeral, and also the port number, which is 80. So I'm going to keep this as is, click done, and then backend configuration. In this backend configuration, click on the list item and choose the create a backend service. The create backend service, I'm going to create this backend service. So it uses the instance group, uses the HTTP protocol, and I'm going to choose the first one. This is for the patient. There are two. The port number is important, so I'm going to use port 80. The utilization here, the balancing modes is used on based on the utilization, based on the rate. What does that mean is the maximum backend utilization is 80. So it is if it goes beyond that, that's being going to be switched to the different instance. That's the balancing mode is. And there is another option, is the rate. It's based on the number of the requests per second, and that's basically what it is. You could use this. So I'm going to use for the utilization option, the maximum backend utilization is 80 percentage. So I'll leave this as is. Enable the cloud CDN. What's the cloud CDN? Is a content delivery network, where if you want to improve the performance by caching the static files, then you would better choose the enable cloud CDN option. I'm going to enable this. And rest of them, in the health check, I'm going to pick the one which I created. Enable logging, and I don't want to enable the logging right now. So that basically is the advanced configuration. I'll leave everything as is. Click the create, and I'm going to create one more. So before I create another one, this is for my patient. So click OK, then click create. So I need to give the load balancer name. So click create. So load balancer creation gonna take a little longer. So let's wait for a second. The load balancer is created, which is my load balancer one. So which uses one instance group. Let me click on it. So when I click on it, it shows the front end, and front end says that 343658, and that is basically um, this route. So people gonna use to route the traffic into the cloud load balancing. So that's basically that URL. So let's go here and paste it. Now enter. If you see, it's coming from it's actually working. It's coming from the instance group 1, patient, QDPP 10128. So if I click on it, see this how the load balancer is automatically routing to different virtual machine within that managed instance group. So what I do is I'm going to create the similar setup. If I go back to my load balancing, click on edit, and you see this add front end IP. Click on this. So if you look at this routing rules, I'm going to create another one. This is basically I'm going to copy this IP address. I don't want HTTP here. So / patient. So click update. Oh, I'm going to use this backend service one. Click on this. It's going to take a little longer. So what I should do now is I go back to underneath, I go to my compute engine, go to the my VM instance. So basically the patient microservice, it routes into the instance. You see this, the instance group 1 patient, so this one. So here I want to create a folder called patient where I'm going to deploy that microservice, a sample microservice. Let's see how to do it. Click on it. When I click on it, it will give a pop-up to all. Click on it. Actually, I'm actually connected to the actual VM. This VM IP address is this one. I'm connected to this. So let's go here and pwd. So I need to go back to var www.html, and here is the one, the index. Now here I'm going to create, I need to log in as sudo and pwd make patient. Now cp index to patient. Now what I'm going to do is go to the next one. This is another VM within that same managed instance group. Authorize it. Now you are connected to the second one. Now let's do sudo su, go to var www html, so index.file. Here I'm going to create a patient. So I create a patient or patients, patient, good. So index.patient. Nice. So what I'm going to do is I created this folder and assume that this index.html is the file I copied over here. It's like kind of a microservice. So I copied that folder and put it over there. Now let's go back to the load balancing. In that load balancing, I edit. So in that load balancer, I need to edit it. Go to the routing rules. So in that routing rules, I see 34, 436 and hyphen patient. I mean 36 / patient, which is the microservice I just created. So what I'm gonna do here, go back here. In that boom. So working. So when I just do 34, 36, 58, 136, and that's basically the HTTP URL. So I go here, refresh. Remember, this patient is routed to actually different the virtual machines, but within the same managed instance group, and absolutely without any change to the URL. So actually this is working. So what we're gonna do now is basically go back to the load balancer. Now I go to the load balancer, click edit. In the backend configuration, remember I have one backend service. That backend service is basically, now I need to go and create another backend service. Instance group provider 80, done, create. Oh, sorry, there is an issue. I need to select the health check. Click this one. Then I'm going to create another backend service for payer. Instance group payer. I need to select the health check which I created. Click on it. So now I have a three backend service like the way backend service, one for patient, provider, and payer. And click OK. Update. Oh, routing rule needs to be configured. Yes, because I created that. So that boom. So it's actually I need to update it. Give a few minutes. So it's gonna work. Now the load balancer has been created with the three backend services. So let's take a look at. So three backend service. The backend service one, that's for the patient. Second one for the payer and the provider. So let's go to the load balancer and click on it. I can use this URL. So / patient. So it goes to the patient 82 WM. So it automatically route and load balance it based on the incoming traffic. Let's do the payer. So same thing for payer, also for provider. So let's do. So the payer is also routed to the. It's basically what our load balancer architecture is. So the load balancer which we created with three managed group instance, with three backend service, based on the URL, it routes to the different instance group, and that's how basically I configure it. And you could try it on your own in your Google Cloud platform. And basically, this concludes our presentation. We created a microservices for patient, provider, and payer health record microservices using Google Cloud Platform. I hope you enjoyed this video. If you do, if you like this video, please like it, share, and subscribe to our channel. Thank you very much.